Hello everyone, welcome back to my YouTube channel. So today we are starting with maximum and minimum value of quadratic functions. So let's start with general equation of a quadratic function. So we write it as f of x is equal to ax square plus bx plus of c. So over here we have x, which is a variable, and we take x from set of real numbers. By substituting it over here, we get some value that is also a real value. So we write y is that real value which is the result of this equation, ax square plus bx plus c, and y also belongs to set of real numbers. So this is our general equation. All right. Whenever we are drawing a curve for quadratic equation, we get a parabolic shape. So either the curve will be like this or it will be like this. So from here we get a parabolic shape, and since the curve is drawn in a 2D space, so it gives some intersecting points with x and y axis, and this particular point over here is the point of minimum value or the point of maximum value. We'll find out all these things, how to calculate these particular values. Let's proceed with that. So now, as I told you, the curve that this quadratic equation forms is a parabolic curve. Now, the shape of that curve is either downwards or it is either upwards. So when the shape is downwards, we get a minimum value. And when shape is upwards, we get a maximum value. How do we know that when we are getting a minimum value or maximum value, what is the orientation of the curve? For that, we compare the given equation with the general equation, that is y is equal to ax square plus bx plus of c. And if the coefficient of x square a is actually less than 0, okay, so if a is less than 0, what we get is a maximum value. Comparing the given equation with the general equation, if we are getting a is greater than 0, then we are getting a minimum value. What these a's tell us, that if we are getting value of a that is negative, it means shift in the curve is negative. That means earlier the curve was increasing, now it is decreasing after this point. So the shift is negative, so the orientation will be the curve is going upwards, and then after the maximum point it starts downwards. So that when a is less than 0, we get a minimum value when the value of a is greater than 0, because it's positive shift. So shift is positive, it means earlier the curve was value curve was decreasing, after that it start increasing. It's a part of differentiation as well, so it's somewhat related to that topic, but we'll not go in detail in differentiation. We'll continue with it. So whenever, okay, simple points, whenever the value of a is negative, it means shift is negative. So shift negative means earlier the curve was increasing, after that particular point the curve starts decreasing. Shift is positive, the curve was decreasing, and after this point the curve starts increasing. All right, so this is what we get to know from a. We get to know that what type of orientation the parabola will follow, and this type of orientation depends only and only upon this coefficient of x square. Now we got to know that we are getting some point of maxima and minima, right, in the curve, but how do we calculate that? So a general equation is y is equal to ax square plus bx plus of c. So from here, if I convert this equation, So if I transform it to an equation, that is y is equal to a x minus h whole square plus of k. So from that, h comma k is the point of maxima or minima. We also call it as point of vertex, right? So we also call it point of vertex. And this particular vertex point is either the point of maxima or point of minimum value. How do we calculate that? So with the help of completing the squares, we have a plus b whole square. That gives us a square plus 2ab plus b square. So I'm taking capital A's because same variables are over here. To avoid confusion, I'm writing this. So if I want to convert this equation to this one, what I will do, I will take a common. I get x square plus b by ax plus of c. I will ignore this constant value. So by completing the square method, what I will do, this particular value is of 2ab. A over here is x. We just need to find out 2b. 2b is b by a. That means b is equal to b by 2a, right? We need to add b square over here for completing the square. So b square is b square by 4a square, right? So this is b square. So we'll add and subtract it. What we get is y is equal to a x square plus b by ax plus b square by 4a square minus b square by 4a square plus of c. That is equal to x square plus b by ax plus b square by 4a square minus, now this a gets multiplied, we can write b square 4a plus of c. So I can convert this to whole square. What I get is a x plus b by 2a whole square and minus b square by 4a plus of c. So what I can say is, from here, h is equal to negative b by 2a and k is equal to negative b square by 4a plus of c. So these are the values of h and k if we directly want to calculate them from the equation. Otherwise, we can convert this given quadratic, whatever the given quadratic equation is, to this form, which is the journal equation of completing the squares. And from here, we can compare what are the values of h and k. All right, let's continue. Now, what we need to find is intersecting points of the quadratic equation with x and y axis. So let's say this is my curve for the quadratic equation. Since it's in 2D, so we have a y-axis and x-axis. Now, these 2 points are the intersecting points of x-axis with the curve, and this is the point of vertex, and this is the point where the y-axis gets intersected with the curve. So this means that x-axis has equation y is equal to 0. Y-axis has equation x is equal to 0. So when I substitute these values in the given equation of the curve, I will get these 2 points which satisfy the given equation y is equal to 0 as well as the given quadratic equation. So let us take the quadratic equation as ax square plus bx plus of c, right? So from here, whenever I substitute y is equal to 0, I get just the quadratic equation, which is ax square plus bx plus of c is equal to 0. So from here, I will get x is equal to either p or q, right? So the intersecting points that I will get are p comma 0 and q comma 0, right? So these are the two intersecting points. So let's say this is p comma 0, this over here is q comma 0, and this is the point of vertex, that is h comma k, and we have one more point over here. That will be, now if I substituted y is equal to 0 over here. If I substitute x is equal to 0, what I will get? I will get y is equal to c. So the coordinate that I will get is 0 comma c. So that will be the intersecting points of y and the curve. So 0 comma c. I hope it is clear. Let's start with the questions. So first question says, use the symmetry of each quadratic function to find the maximum or minimum value points. All right. So first of all, we need to check and compare this quadratic equation with the general equation ax square minus 6x plus of 8. From here, if I compare it, I get a is equal to 1. So a is greater than 0. It means what I will get is a point of minimum value. So it means my vertex h comma k is a point of minimum value, right? So h comma k is a point of minimum value. Now it means the orientation of the curve will be like U shape. Okay, so we got the orientation. We have to calculate this point of vertex and sketch each graph showing all axis crossing points. Okay, so we also need to find the intersecting points of x and y axis. Let's start. First of all, let's start with finding the vertex. So we'll convert this equation by completing the squares. So for that, y is equal to x square minus 6x plus of 8. It means this particular number is 2 times b. So b is 3. So from here, what we'll do, we'll add and subtract b square plus 9 minus 9 plus of 8. So now what we'll do is convert this quadratic equation into completing the squares. So we'll convert it into whole square form, and we have a constant over here. So we get x and minus of 3 whole square and minus of 1. So if I compare this with y is equal to a x minus h whole square plus of k. So from here I get h is equal to 3 and k is equal to minus 1. So the point of vertex is equal to 3 comma negative 1. So this is the point of vertex, right? And we knew the orientation already. We got the point of vertex, now intersecting points with the x and y axis. So intersecting points are, so if I take y is equal to 0, what I get is x square minus 6x plus of 8 is equal to 0. Product is 8, sum is negative 6, that is x square minus 4x minus 2x plus of 8 is equal to 0. Taking x common, x minus of 4, taking negative 2 common, x minus of 4 is equal to 0. So from here what I get is x minus of 4 and x minus of 2 is equal to 0. So I get x is equal to 4 or x is equal to 2. This is when y is 0. It means these are the intersecting points with the x-axis. So the coordinates for these 2 points are 4 comma 0 and 2 comma 0. Now if I take x is equal to 0, that means I am finding intersecting point, the curve with the y-axis. So for that, what I get is y is equal to 8. 0x square minus 6 times 0, 0, just 8. So coordinate that I will get is 0, comma 8. All right. So this will give me a curve. So this is the curve. The vertex point over here is 3 comma negative 1. So it's 3 comma negative 1, and the intersecting points with the x-axis are, so this point is 2 comma 0, this point is 4 comma 0, and intersecting points with the y-axis is 0 comma 8. So somewhat over here, So it passes like this. So it's 0 comma 8. So this is the type of curve that the quadratic equation was forming. We got the intersecting points with the x-axis, intersecting point with the y-axis, point of vertex, and we also got the orientation, how the curve is going. Is it the point of vertex is either the point of maximum value or minimum value? That we calculate by comparing with a coefficient of x square. I hope I made it clear. Let's try next question. All right. So this is also a very simple question. We'll compare this with y is equal to ax square plus bx plus of c. From here, what I get is a is equal to 1. And this tells us that a is greater than 0. So h comma k, the point of vertex, is a point of what? It is greater. The orientation is has a positive shift. So earlier it was decreasing, now it is increasing. So h is a point of minimum value, right? So it's a point of minimum value. Let's continue. So we got to know what is the orientation of the curve, that is like this. Now we need to find this point h comma k. Let's try. So by completing the squares method, y is equal to x square plus 5x minus of 14. So we'll ignore this negative 14, we'll work over here. We get x, and since this is 2b, so b will be 5 by 2. So b square will be 25 by 4. So 5x plus 25 by 4 minus 25 by 4 minus of 14, right? So from here, I can convert this to a whole square, that is x plus of 5 by 2 whole square, and this can be written as negative of, I can take 4 as LCM and I get 25 and minus of 56, right? This gives us x minus of minus 5 by 2 whole square and minus, so we can take it as 25 plus 56 gives us 81 by 4. So from here what we get is h is equal to negative 5 by 2 and k is equal to negative 81 by 4. So these are the two values of h and k. So the point of vertex is minus 5 by 2 and minus 81 by 4, right? Now we got the orientation, we got the point of vertex. Now what we need to find is how which are the intersecting points of curve and the x and y axis. So let's find those. So we'll take y is equal to 0. So we get x square plus 5x minus 14 is equal to 0. So from here, product is 14, product is negative 14, sum is 5. So x square plus 7x minus 2x minus 14 is equal to 0. We'll take x common, x plus of 7 minus 2 common, x plus of 7 is equal to 0. X plus 7, x minus 2 is equal to 0. X is equal to negative 7, x is equal to 2. These are the two values of x. So it means the intersecting points are negative 7 comma 0 and 2 comma 0. All right, let's continue. We get we took y is equal to 0 for finding the intersecting points with the x-axis. Now I'll take x is equal to 0 for finding intersecting points with the y-axis and curve. So this equation is actually x is equal to 0. Each and every point in this line has x as 0. This is the equation of this line. Now intersecting point of this line and the curve will give us y is equal to negative 14, because x square becomes 0, 5x becomes 0. So y is equal to negative 14. It means intersecting point is 0 comma negative 14, right? Now if we try and plot this, we are having a point of minimum value. So that particular point over here is negative 5 by 2 and negative 81 by 4. So negative 5 by 2 is negative 1.25 and negative 81 by 4 is negative 20.25. So these are the points of um, vertex, and intersecting points with the x-axis are, we have x is equal to negative 7 and x is equal to 2. All right, so we can take it over here. So x is negative 7 comma 0 and this is 2 comma 0, and we also have intersecting point with the y-axis, that is somewhat over here. So this point is 0 comma negative 14. I hope I made it clear. Let's move to next question. All right, comparing it with the general equation y is equal to ax square plus bx and plus of c, we get a is equal to 2. A is greater than 0. It means the point of vertex h comma k is a point of what? Minimum value, right? So we have h comma k as a point of minimum value. All right, we got to know the orientation with the help of a. It means the curve will be like this. Let's find this point. So y is equal to 2x square plus 7x minus 15. We take 2 common. So we get x square plus 7 by 2x minus of 15. So 2b is 7 by 2. It means b is equal to 7 by 4. It means b square is equal to 49 by 16. Right? So y is equal to 2 times x square plus 7 by 2x plus 49 by 16 minus 49 by 16 minus of 15. 2x square plus 7 by 2x plus 49 by 16, and we take this out, we get negative of 49 by 8 minus of 15. So 2x plus 7 by 2, 7 by 4 actually, so 7 by 4 whole square, and negative of, so if we take this 8 over here, we get 49 minus 120 by 8. So from here what I get is 2x plus 7 by 4 whole square minus of, now if I add this I get negative 169 by 8. So from here h is equal to negative 7 by 4 and k is equal to negative 169 by 8. I hope I made it clear. And the coordinate of the vertex points are negative 7 by 4 and negative 169 by 8. Clear? Now, we already know the orientation. We got to know the vertex point. Now, what we need to calculate is the intersecting points with the x and y axis. So let's bring our equation. So to find intersecting points with the x-axis, we'll take the intersection with y is equal to 0 and the curve. So y is equal to 0. When we substitute this in the curve, we get 2x square plus 7x minus 15 is equal to 0. So from here, if I check, the product is negative 30, sum is 7. So for that, what we can write it as 2x square plus 10x minus 3x minus 15 is equal to 0. If I take 2x common, I get x plus a 5. If I take negative 3 common, x plus a 5 is equal to 0. X plus 5 and 2x minus 3 is equal to 0. So I get x is equal to negative 5 or x is equal to 3 by 2. So these are the two coordinates where I am getting the intersecting points of the curve and x-axis. Those are negative 5 comma 0 and 3 by 2 comma 0. Now intersecting points with the y-axis, x is equal to 0. If I substitute that in the equation, I get y is equal to negative 15. I already know the orientation, and 0 comma negative 15 is the point of intersection of the curve and the y-axis. So if I draw the curve, so this is the orientation of the curve. Point of vertex is negative 7 by 4, negative 169 by 8. So negative 7 by 4, negative 169 by 8, right? And the intersecting points with the x-axis are, so if I substitute these, negative 5 comma 0, 3 by 2 comma 0, right? And intersecting point of the y-axis, it will be somewhere around here. So this I get as 0 comma negative 15. All right, I hope it is clear. Let's go towards the next question. So from this question, first we need to rearrange it. We get y is equal to negative x square plus of x plus of 12. So if I compare it with y is equal to ax square plus bx plus c, I get a is equal to negative 1. A is less than 0 in this case. It means h comma k is a point of maximum value, right? So h comma k is a point of maximum value. Orientation of my curve will be like this for obtaining a maximum value, which is h comma k. So let's find this point h comma k. For that, what we'll do, y is equal to negative x square plus x plus of 12. So by completing the squares method, first of all, let's take this negative 1 common. So negative x square minus x plus 12. So 2b is 1. B is equal to 1 by 2. B square is equal to 1 by 4. So I need to add 1 by 4 and subtract 1 by 4. Y is equal to negative x square minus x plus 1 by 4 minus 1 by 4 plus 12. So y is equal to negative, what I get is x square minus x plus 1 by 4. I take this negative 1 by 4 out, I get positive 1 by 4, because negative times negative is positive. We have this negative 1 in multiplication over here. So plus of 12, and what I get is y is equal to negative x minus 1 by 2 whole square and plus of 49 by 4. So if I compare it with y is equal to a x minus h whole square plus of k, I get h is equal to 1 by 2 and k is equal to 49 by 4. It means a point of vertex is 1 by 2 comma 49 by 4. All right, so this is the point of vertex. Now let's continue. We need to find the intersecting points. So for intersecting points, what we'll do is we'll compare our equation and we'll find the intersecting points of the curve with the x and y axis by substituting y is equal to 0 for finding intersecting points with x axis. So from here we get negative x square plus x plus 12 is equal to 0. Product is negative 12. Sum is x. It means sum is 1. It means negative x square plus 4x minus 3x plus 12 is equal to 0. It means if I take negative x common, I get x minus of 4. And if I take negative 3 common, I get x minus of 4 is equal to 0. So x minus 4 and minus x minus 3 is equal to 0, I get x is equal to 4 or x is equal to minus 3. So these are the 2 points. Coordinates are negative 3 comma 0 and 4 comma 0. Now to find the intersecting points with the y-axis. So I will take x is equal to 0. So I get y is equal to 12. If I substitute y is equal to 12, the coordinate that I'm getting is 0 comma 12. Okay, so we got this. And point of vertex is 1 by 2 comma 49 by 4. So let's draw this curve. So orientation of the curve is now we since the vertex point is point of maxima, so it will be like this upwards, right? Point of maximum value is 1 by 2 and 49 by 4, right? So this is what we are getting, 1 by 2 in x and 49 by 4. And intersecting points with the x-axis are negative 3 comma 0 and this is 4 comma 0, right? And intersecting points with the y-axis is, we draw it like this. So this is the intersecting points. It is 0 comma 12, right? This curve is upwards. All right, I hope it is clear. I hope there is no doubt. Thanks for joining. We'll continue next question in the next class.